micrometer screw gauge. Introduction. A micrometer screw gauge, or simply a screw gauge, is an instrument designed for precision measurement of small dimensions such as the diameter of a wire, thickness of a sheet, etc. The principle behind a screw gauge is that when an accurately cut screw works in a fixed nut, the motion of translation of the screw is directly proportional to the amount of rotation given to it. The essential components of a screw gauge are a curved metal frame and an accurately cut screw, which can be rotated by means of a ratchet. On the frame are mounted an adjustable anvil aligned with the flat tip of the screw and an accurately cut nut. The head of the screw is fixed to a thimble so that turning the thimble also rotates the screw. The thimble moves coaxially over a cylindrical sleeve fixed firmly to the frame. The sleeve carries a millimeter or half millimeter scale called the main scale. The tapered end of the thimble is divided into 100 or 50 divisions called the circular scale. The index line etched along the main scale on the sleeve is used as a reference marker to read the circular scale. Aim: to measure diameter of a wire using a micrometer screw gauge and find its cross-sectional area. Apparatus: a micrometer screw gauge and 2 pliers. Procedure: let us first determine the least count of the micrometer screw gauge. The least count LC of micrometer screw gauge is defined as LC is equal to pitch of the screw P upon number of divisions on the circular scale N. Note the value of one division on the main scale. It is 1 millimeter or 0.1 centimeter. Note the total number of divisions on the circular scale of the micrometer screw gauge. There are 100 divisions on the circular scale. To find the pitch of the screw, give 10 rotations to the screw and find the distance moved by the screw on the main scale. The pitch of the screw is given by expression pitch of the screw is equal to total distance moved upon number of rotations is equal to 10 millimeters upon 10 is equal to 1 millimeter or 0.1 centimeter. Hence, the least count LC is equal to P upon N is equal to 0.1 centimeter upon 100 is equal to 0.001 centimeter. Let us check whether the given micrometer screw gauge has any zero error. When the screw gauge is closed completely, the zero mark on the circular scale should coincide with the index line of the main scale. If they are coinciding, then the instrument has no zero error. But if they are not coinciding, then there can be two types of errors depending upon the position of the zeroth line of the circular scale relative to the index line of the main scale. If 0 of the circular scale is below the index line, then the error in the instrument is said to be positive. If X is the coincident division with index line on the main scale, then the positive zero error Z is given by Z is equal to plus X into LC. If 0 of the circular scale is above the index line of the main scale, then the error in the instrument is said to be negative. If Y is the coincident division with index line on the main scale, then the negative zero error Z is given by Z is equal to minus N minus Y into LC, where N is the total number of divisions on circular scale. The observed reading is corrected by applying formula. Correct reading is equal to observed reading minus 0 error. Let us now turn the screw by slowly turning the ratchet till the screw touches the anvil. Check the position of zero line of the circular scale relative to the index line. Are they coinciding? No. Can you tell the type of the error involved? The zero line of the circular scale is above the index line of the main scale. Hence, the error is negative. Here, 98th line of the circular scale coincides with the index line. Hence, the negative zero error in the micrometer screw gauge is Z is equal to minus N minus Y into LC is equal to minus 100 minus 98 into 0.001 centimeter. Z is equal to minus 0.002 centimeter. Any measurement using this micrometer screw will be less by this amount. Hence, the corrected reading is obtained by adding this correction to the measured reading. Now, we will measure diameter of the given wires using screw gauge and tabulate the readings. For this, let us draw a table with column names object, observation number, main scale reading A in centimeter, coincident circular scale division B, circular scale reading C is equal to B into LC centimeter, total reading A plus C centimeter, and correct reading A plus C minus Z centimeter. Let us first use thick wire as our object. To find diameter of the wire, open the screw and hold the wire in between the head of the screw and the anvil. Now, slowly turn the ratchet in till it sleeps. A clicking sound indicates that the screw gauge is closed. Now, observe carefully the position of the edge of the circular scale. The value of the main scale division just preceding the edge of the circular scale gives the main scale reading A. It is 0.1 centimeter here. Hence, the main scale reading is 0.1 centimeter. Also note circular scale division B coinciding with the index line. 69th division is coinciding with the reference line of the main scale. Record A and B in the observation table. The circular scale reading C is given by formula C is equal to B into LC. Hence, C is equal to 69 into 0.001 centimeter is equal to 0.069 centimeter. The total reading is A plus C, which is equal to 0.1 centimeter plus 0.069 centimeter is equal to 0.169 centimeter. The correct reading is given by A plus C minus Z is equal to 0.169 minus 0.002 is equal to 0.171 centimeter. Let us take readings at 5 different points along the length of the wire. Tabulate all observations. Now, use the thin wire as the object and take readings of the diameter at 5 different points along the length of the wire. Tabulate all observations. Calculations. Calculate the corrected mean diameter of the thick wire. D mean is equal to 0.171 plus 0.174 plus 0.172 plus 0.173 plus 0.175 upon 5 is equal to 0.173 centimeter. And hence, radius of the thick wire is R is equal to d mean upon 2 is equal to 0.173 upon 2 is equal to 0.087 centimeter. Now, let us calculate area of cross-section of the thick wire using formula A is equal to pi r square is equal to 3.142 into 0.087 square is equal to 0.024 square centimeter. Similarly, the area of cross-section of the thin wire is found. Let us write the results of the experiment. Results: 1. Area of cross-section of the thick wire is equal to 0.024 square centimeter. 2. Area of cross-section of the thin wire is equal to 0.006 square centimeter. Precautions. While doing experiment, following precautions are to be taken. 1. The zero error is subtracted algebraically in either case, positive and negative zero error. 2. While taking a reading, slowly turn the ratchet in till it sleeps. 3. If required, use a magnifying glass to see the coincident circular scale division. 4. Take several readings at different positions of an object. 5. Express the result in the correct number of significant figures.